Here's part B of number 6 from the 2014 AB exam. They have this differential equation given to us, and then in part B they say write an equation for the tangent line to the solution curve at the point 0,1. Use the equation to approximate f of 0.2. So we'll focus on the first sentence in part B first here, and we want to find an equation for the line tangent to the solution curve at this location. So if we want to know the line tangent to the solution curve, we're going to need to know the slope of the tangent line evaluated at 0,1, and that's going to correspond to the derivative evaluated at 0,1. So this is going to be pretty simple to do. Derivative depends on x and y here, so we're going to put 1 in place of y, right? We're evaluating the derivative at 0,1. We're going to put 0 in place of x. And if we go ahead and think about what this simplifies to, 3 minus 1 is obviously 2, and then cosine of 0, that actually is 1. So the slope of our tangent line is 2. Now what's our point of tangency? Well, 0, 1. They give it to us. We don't even have to find it. So we need to write the equation of the line that goes through this point and has a slope of 2. So using point slope form, I'm going to have y minus y1, so y minus 1 equals m times the quantity x minus x1 is 0. Here is an equation of the tangent line. So there's an equation of the tangent line to the solution curve. Use the equation to approximate f of 0.2. Well, what we can say is we can say that the y value on this line is going to be really, really close to the y value that's on this curve at the x value of 0.2. Because if I go back, actually let me go back again, if I actually draw in the tangent line, and it's going to, I guess I'll use this to do it. If I draw in the tangent line to the solution curve through this point, the tangent line is going to look something like that. At the x value of 0.2, which would be somewhere in here, you hardly see any difference on my graph between where the blue curve is and where the black tangent line is. So the y value on the tangent line is practically right on top of the y value on the curve as long as we're close to the point of tangency. Now obviously they start to distance themselves in this portion of the graph, but on this piece of the graph, the tangent line and the curve are practically right on top of each other. So what is the y value on the curve at the x value of 0.2? So I'm going to add the 1 to the other side. So I'm going to have 1 plus 2, and then if I distribute in, I just get 2x. And if I want to do my approximation, I'm going to be able to say that f of 0.2, or f of 1/5, is not equal to, but approximately 1 plus 2 times 1/5. Well, that would be 1 plus 2/5, and that would end up being, what, 7/5? So our approximation for the y value on the curve at 0.2, or the function value at 0.2, is going to be 7/5, or 1.4. If you come back to the graph, here is the y value of 2, here's the y value of 1, where's the x value of 0.2? Probably somewhere in here. You know, do we have a value that's halfway between 1 and 2 on my sloppy graph here? Yeah, it looks to be the case. So it seems like that estimation is definitely reasonable.